Oh, I guess not. Now I can start. All right, when last we met, we were looking at a game that looked something like this. Where we click the ball and it gets faster and the score goes up. And if I miss the ball, my lives go down. And then at some point, we get a click to restart button. So hopefully you've all made it this far, yeah? And if I click the button, hey, look at that, I restarted. Woo! All right. So hopefully we are there. The next thing I want to talk about, though, is kind of cleaning this up because it's getting kind of unwieldy, especially now if we want to add like a starting screen. If we want to add a game starting screen to this, it's getting hard to think about where that might go. And so I want to talk about a way of organizing your code just to get us to think differently about how we do things. So I'm going to jump up to the whiteboard and make sure that this is recording with a decent microphone. Yes, it is. Okay. Zoom in a little bit more. All right. So first off, we need to talk a little bit about the difference between a variable and a function. From looking at a lot of the stuff you guys have written in your things and or talked about in your reflections, many of you are a little unclear on variables versus functions. So we have two things. We started by talking about functions. And then we also have variables. These are actually two very distinct and different concepts. They seem to be very similar, but they are very different, okay? So what do we know about functions versus variables? Who can tell me something? Anything? Yes, Bella?
Functions include variables in them.
Functions can include variables in them. Anything else that we know about functions versus variables? Anybody tell me what a variable or a function is? Anybody give me a definition of a variable or a function? Nobody? All right, Lindsay, what do you think? Can you define either variable or function?
I don't know.
I don't know. Okay. Can you tell me something different about them?
Well, wouldn't a variable be like a number?
I can't hear you.
Wouldn't a variable be a number?
Wouldn't a variable be a number? It can be. Often, but a variable itself is not a number per se. I understand where you're coming from.
Isn't it like a letter or a word you use to represent a number?
So we typically use some sort of letter or word, and that ends up representing a number, but I'm going to put this kind of in quotes.
Because they can be substituted in the arguments.
Because we can put those in various places, right? As an argument or a parameter. All right. So what it actually is, a variable stores a piece of information, okay? A variable stores a piece of information. That piece of information so far, that piece of information for us has always been a number. It can also be a string, which is a word or a sentence. You can actually store that in a variable as well. So what a variable does is when we declare a variable, it reserves a piece of memory space for us to store information in. And then the label we use, that word or letter, allows us to access that memory space to see what's in that memory space. Does that make sense? So a variable stores a piece of information. How is that different than a function? How is storing a piece of information different than a function? Or are they identical? Well, they got different names, Mr. Dickey, so they must be different. What do we use functions for? Let me ask that question. What?
Multiple things.
Multiple things. Have you created your own functions?
Yeah.
Okay, why did you create a function? Don't say because Mr. Dickey told me to.
Because Mr. Dickey told me.
What's
Because it's
For the grade.
that?
Because it's like easier to, instead of typing out like a set of code like multiple times, like it's just easier to call it once.
So,
I don't know.
okay, I like the thinking out loud, right? So you were saying, so we could type a set of code, and rather than having to type that set of code multiple times, we could type it once and then just call it multiple times, right? That seem familiar? So,
It's a shortcut.
what's that?
It's a shortcut.
I can't hear you now.
It's a shortcut.
It's a shortcut. We like shortcuts. So a variable is kind of like that also, right? But a variable is just a single piece of information. What's a function? It's a list of instructions, right?
Yeah.
A function is a list of instructions. Okay? So a function is a list of instructions. A variable is a single piece of information. So far, so good? Now, I know this all seems fairly straightforward, but when we start using them, we want to make sure that we're using them appropriately and we're thinking about them appropriately. So and I understand why students are kind of putting the two together, kind of making them synonyms of each other. Because when we do variables, we have to create the variable, right? By using the let x get 17 type of thing, right? Where this statement creates the variable. It's actually, the nerd word would be declare the variable, okay? And then when we do the gets 17, we are giving the value. That's called initializing the variable. So I could actually do that in 2 steps if I wanted to. So if I say, lowercase l, let x, this line right there, I'm going to comment it out here, declares the variable. Yes.
So just asking, are you able to say that like variables are used when like defining certain things in the function, and then the function is when it's actually being called?
I don't know.
Like,
I understand. I understand the words you're putting together, but I don't necessarily see the concept. So let me finish this, and then we'll get back to your idea. All right. So let x declares a variable, and it names it x. X gets 17. This is called initializing. And I probably spelled initializes wrong. All right, that initializes it. These are the nerd words. So in programming lingo, you may run into these words, which is why I'm hammering them. If we do it in one go like this, let y get 12, this statement, this line declares and initializes it in one line. Does that make sense? Initialize means to give it its first value. Initialize it means to give it its first value. So we can do that in 2 lines, or we can do that in 1 line. So far, so good. And then anytime we want to refer to it, we just have to ask what's stored in X or what's stored in Y. Or if we want to change it, we just say X gets something new or Y gets something new. And we can add things to it, or we can just change it completely, right? Because we could say something like, when we were causing the ball to move, we said something like x gets x plus speed, right? And that's going to increase the value. That's going to say whatever's in x, add speed to it, store it back in x. So we can do that, but if we wanted to just make the ball teleport somewhere, we could, rather than doing that, we could just say x gets some number like -10. So then it goes all the way over to the left side of the screen again, right? So far, so good? But it's only a piece of information. You with me? It's just one little piece of information, and it includes no instructions. A variable includes no instructions. This x only means the position of our ellipse because of how we use it. Speed only means how fast the ball is moving because of how we use it. There's nothing inherent in the word speed. Make sense? It's only on how we use it. This is different than a function. So it's similar because it seems like, hey, we're defining the function and now we're calling the function, but that's not what it is, okay? So they're similar, but they're not actually the same. They're similar in that we have to define it and then we use it. When we use a function, we are calling the function. What that literally means versus a variable, the variable just keeps cruising on in your code. With a function, if I've got a function draw, and then I've got stuff, and then I call another function like draw robot. Then I got more stuff. So far, so good. What's going to happen is when draw is going, it gets to here. It does all the stuff, all the code that might be there, gets to draw robot. It leaves the draw function and goes to the draw robot function. Am I going to still be on the screen? Yeah. So I'm going to, as if we're further down. And then I might have something like ellipse, 100, comma, 50, comma, 50, comma, 50. And I might have rect, 80, comma, 50, comma, 40, comma, 40, or 400, I don't care. Anyway, I have something like that. So what's literally happening is when we run a program, we go, in our function, we go line by line by line by line until we get to here. And then we leave this, we jump over to here, and then we go line by line by line till here. And then we jump back and then we continue going line by line. Does that make sense? So when we call a function, we are literally stopping everything we're doing. We jump over to a new chunk of code. We do that code line by line until we're done with it. And then we jump back to where we left off. With a variable, we're running along and we just kind of glance over and say, oh, it's a 7. Oh, it's a 12. We just keep going. But we're not running any new code when we do that. That's kind of the big difference. This chunk over here defines our function. Not just this line, this whole thing is the definition of our function. This first line just tells us what its name is. And if there's any parameters in here, it tells us what our parameters are. Then all of these instructions are also part of that function. So this whole thing is the function definition. And then when we call it, we just use its name with the parentheses. And if we need to, we put numbers in there. Does that kind of make sense? It's a fundamentally different idea, but in both cases of functions and variables, I understand why there's some confusion on it and why we kind of put them together in our minds, because we're doing something called abstraction. Does anybody know what the word abstract means? You know what the word abstract means? Have you ever seen an abstract painting? So what does it mean to have an abstract painting? I don't know, Mr. Dickey. Abstract things are usually not perfect representations of what they are. So there's a couple different ways we use abstract. In And in programming, we use abstraction all the time. Typically, we use one thing to represent something else. You with me? We use one thing to represent something else. So for me, when I go to the grocery store, my little piece of plastic I carry around in my pocket represents my money, right? Is the little piece of plastic actually money? No. But the little piece of plastic, I just go stick it in the thing, let it talk to the bank, and suddenly, bam, there's my money, and I can buy my groceries. So that piece of plastic is kind of like an abstraction for my money or my bank, right? Because really I can go to a money machine and it's like I'm talking to the actual teller. And because if you think about it, abstractions get used a lot to manage all sorts of complexity. Back in the day, before I could use my debit card for my bank account, I would have to, if I wanted to actually take the money out of my bank account to pay for my groceries, I would have to go to the bank and get money and then carry the money with me. But that debit card now makes my life so much easier. It's managing the complexity of going to the bank, finding the time, getting the money, having to talk to somebody. I don't like talking to people. That's why I'm a teacher. And then going to the grocery store to pay, right? All that complexity is now managed because I just got this little piece of plastic and I just type in my PIN number, bam. The same thing is true here. When you guys wrote that draw robot function, suddenly you could just say draw robot and it would draw your robot. You didn't have to remember what the code was and retype the code every time. And then by adding those parameters, you could make it draw the robot anywhere on the screen without having to think about it, right? That's really cool. The same thing is true of our variables. We use our variables, they store information somewhere in the memory of the computer, and we use them, as Bella said, to represent the number. And then we can change that number and still keep it stored in that variable. So they're abstractions. We do abstractions to manage complexity in our program. You with me? Abstraction helps us manage complexity. And there's two ways that it can help us manage complexity. We've got way number one, which is I don't want to type the same code over and over again, right? That's one way we can manage some of the complexity. And way number two is help us think about it conceptually. You with me? Help us think conceptually. You with me? Which can really help us out. And then it can also help us learn how to break down a problem. It can help us learn how to break down a problem. So far, so good? So when we think about the code we wrote for our simple game, which is getting more and more complex as we go, right? There are a number of tasks. A good function should primarily do one thing and one thing only. You with me? That's what a good function should do, one thing. So we've got our function draw. And inside of our function draw, we've got code to do our background. Then we show our score, right? We move the ball. We draw the ball. These are all things that we are doing when we when our game runs, right? So, and then we the newest piece we just added was that restart button. We check to see. Let's see. Well, I'm going to write this in here. Restart button, maybe, because we don't want the restart button there all the time, do we? And that's really our draw. You with me? So we could take each of those ideas out of draw and have their own function for it, and then we can call them. And when we look at our progression, it's really easy to see them. And we're like, hey, the ball's not moving right. Well, I go to the move the ball function, and then I can tweak the code in the move the ball function. That makes sense? So even though each of these only get called once, we could still break things up a bit in ways that are meaningful so that we could, then when we read it, it's fairly straightforward, right? The other thing is, had we started with this before we wrote the program, we could do it, we could have done that also, right? We could say, what are all the things we need to do? And we could write it in more or less plain English, and then we could go back and code the pieces and by just creating those functions. Starting with that, starting with the big idea in mind, it has a name, it's called top-down design. Where you think about what are all of the things we want to do? So what are all of the functions we might want to create? And you start with that list. And after you've got that list, only then do you start designing the functions. So far, so good? What I want you to do right now is take your game where it stands right now, make a duplicate of it so you don't totally destroy everything you've created. You with me? And I want you to think about if you can start breaking it up into individualized functions. Does that make sense? So I want you to try that and see where you get.